Today we are going to discuss the hexagonal close packed structure. So before this, there are two types of packing in the crystal structure by using the packing of spheres. So these are of two types. First is closed packed structure, and second is of a type loosely packed structure. In closed packed structure we have two types of system. First is hexagonal closed packed structure, and another is face centered cubic packed structure. And in case of loosely packed structure, these are of also two types. First is simple cubic, and another is BCC, body centered cubic packed structure. So in this lecture we are going to discuss hexagonal closed packed structure, its C by A ratio. We have discussed FCC structure, simple cubic structure, body centered cubic structure, and their packing fraction, packing efficiency, their coordination number. So for the hexagonal closed packed structure, we assume that these atoms are hard spheres and they can be arranged in the minimum volumes if their centers of the spheres are occupying the corner of an equilateral triangle. So let us consider a layer of hard spheres or atoms as a hard sphere. These are identical so these layers are A layers, and because our this sheet is a two-dimensional, but this can be looked as this layer is not like this is like this. So this is A layer. So now we will place another layer on this by placing another layer, that is B layer, on these depressions. These depressions. And these depressions. So this layer is B layer. So you can say that hexagonal close packing is of a AB type. So if you consider this is the central atom, so it is the adjacent atom will be this atom, this atom, this atom, this atom, this atom, and this atom in the A sphere. So these are 1 2 3 4 5 6 for this central atom. So these are 6 contacts. So in this direction, in this plane, so in the A layer, so for the B layer, there are, for this there are, this is in the contact and these two also in the contact. So there are 6 and plus 3 9, and there will be another layer on the downward side, in the downward side. So there will be also be the B layer, that is and for the central atom there will be also 3 atom in the contact. So we have 6 plus 3 plus 3, we have 12 atoms for this central atom in the contact. So therefore coordination number for SCP structures will be 12. So this coordination number for the SCP structure will be 12. So if I am taking this layer as this is A layer, this is the central atom. So if you join the centers, so it is traversing a hexagonal. So therefore this types of structure is known as hexagonal close packed. So similarly these three three atoms in the which are in the contact of the central atom, these are like this, because they are inside of this layer, A layer, and there is downward layer of downward A layer. Join these centers. So if you join, so it is making a hexagonal. So if you neatly draw this diagram, this is the central atom, and these three atoms are inside this hexagonal. This plane is also like this. So join these. So this is unit cell for the hexagonal closed packing structures. So we will if you join these planes, this is the perpendicular distance between these planes. This is basal plane, so this will be height C, and this will be A, and we know that what is A is equal to 2R, or R is equal to A upon 2. So now we are going to calculate the C by A ratio for hexagonal closed pack structures. This is very important, and this will also be used for calculating the packing fraction for the hexagonal closed packing structures. So for this, consider this basal plane. So if you consider these these planes. So let us consider this atom and these three atoms which are making the equilateral triangle. So if you connect these, so these are making a tetrahedral structure. So this is a tetrahedral structure. So since we know that this is A, so now we are going to take a perpendicular. So this is like this. So if you take a perpendicular from this surface to this, this will be, so since from here to here this is C, height is C. So if you taking a perpendicular to this plane and to this plane, so from distance from here to here is same, and this from here to here is same because it is in the center. So this will be C by 2 because it is C, so it half will be C by 2. So if you take this perpendicular from this point to this plane, this will be so if for example from here this will be C by 2. So if you consider a triangle, that is this triangle, to this point this is perpendicular, this is because this is A, so this will be C by 2, and this is unknown, this will be Y. So this will, the triangle will be, oh this is perpendicular, this will be right angle triangle, this will be Y, this will be A, and this will be C by 2. So from this right angle triangle we will have, this is hypotenuse a square plus a square is equal to y square base square plus perpendicular square c square upon 4 square of this. So this will be the equation. So now we have to find this y. So for this y we are taking this we are considering this equilateral triangle, So since in case of equilateral triangle this angle is 60 degree, this will be also 60 degree, this will be also 60 degree. So this is, but we are taking a perpendicular, so y is like here, in the middle of this y, and let us consider a perpendicular bisector. So this will be perpendicular bisector, this will be, since this is 60, so if this is bisecting, this is 30 degree, this will be the 30 degree, this angle will be 30 degree. So since this is A, so this will be A by 2, and this is A by 2, this is A by 2, so this is Y. So we have to find y, this is A by 2, so this is 30 degree, so cos 30 degree will be, this is perpendicular, cos will be base upon hypotenuse, base is A by 2 and hypotenuse is y divided by y. So cos 30 degree is under root 3 by 2, this is A by 2 upon y, so y will be A by 2, this will be here, so this will be 2 this will be under root 3 upon 2, so 2 will be cancelled, so y will be A upon under root 3. So we have calculated the value of y, this is A upon under root 3, put this value of y into this equation, so you will have A square will be, put the value of y, this is square, this will be 3 plus c square upon 4. So c square upon 4 is here, and if you take this will be a square minus a square upon 3. So this will be 3a square minus a square upon 3. This will be 2a square upon 3. So therefore c square upon 4, this will be 2a square upon 3. So further this will be c square 8a square upon 3. So therefore c square, if you take the under root both side, so this will be c 8 under root upon 3 into a. So therefore c upon a is equal to under root 8 upon 3. So we will now calculate the packing fraction of this hexagonal closed packing structures. So since we have calculated the c upon a ratio, which is under root 8 upon under root of 8 upon 3, so now we know that what is packing fraction. Packing fraction is volume of atoms in unit cell divided by volume of unit cell. So for this, for the volume, so to calculate the volume of atoms in unit cell, we have to calculate what is the effective number of atoms in the unit cell. So since to calculate this, we know that in this hexagonal closed packing unit cell, we have 3 atoms in the center of this unit cell. So therefore this will be the 3 plus these are on the faces. So there are 2 atoms on the faces. So for this face, this effective number of this will be half of contribution for this unit cell. So since we have 2 face centered atoms, so their contribution is 1 by 2. Because their contribution is half, so we are taking 1 by 2. So we have 2 atoms, therefore this is multiplied by 2 and plus. So since we have these corner atoms, there are 12 corner atoms, 6 and 6, 12 corner atoms, but each atom is shared by another 6 unit cells. These atoms will be shared by the 6 unit cell. This side, this side, this side, this side, this side, and this side. This will be shared by 6. So its contribution to the unit cell is 1 by 6. So the contribution for the corner atom is 1 by 6, and total number of corner atoms are 12. So we will have, that is 3 plus 1 plus 2. This is equal to 6. So effective number of atoms in the unit cell for HCP is equal to 6. So packing fraction will be 6 into volume of atoms. This will be 4 by 3 pi r cube, and volume of the unit cell will be, so this will be the area of this base into height. So this will be area of base into height. Height is c. So if you want to calculate the area of base, so area of base will be like this. So our base is made up of equilateral triangle, 6 equilateral triangle, 1 2 3 4 5 6. So area of base will be calculated by 6 into because 6 equilaterals, area of 6 into area of equilateral triangles. So calculate the area of equilateral triangles. We have equilateral triangle is, this is our equilateral triangle. So area of a triangle is 1 by 2 into base into height. So this is A, this is A, this is A. So base is equal to A. We have to calculate the height. So calculate height, we will take a perpendicular. This is height. So from this triangle we will calculate the height because this is A. So and so if you calculate this, this will be A, this will be H, and this is A. So because this is bisector, this will be A by 2. So from this right angle triangle, so this will be A square hypotenuse का square plus base का square, A square upon 4 plus H. So H will be if you take this will be 4 A square minus A square, this will be 4, this will be 3A square, this is square, this is S square upon 4. So H will be under root 3A upon 2. So area of this triangle will be half into base, which is A, and height is 3 under root 3A upon, that is 2. So this will be under root 3A square upon 4. This will be the area of this triangle. So what will be the volume? Area of base, this is area, because this is for this area for this particular face, because we have 6. So therefore this will volume of unit cell will be 6 into, because 6 faces, under root 3 upon 4 into A square into height is C. So therefore packing fraction will be 6 into 4 by 3 pi r cube divided by 6 into under root 3 upon 4 into A square into C. 6 cancelled, and this will be, so if you calculate, so we have solved this. So this will be the, after solving this, so also we know that what is R is equal to A upon 2. So if you put the value of R in terms of this primitives, so if you put the value of R into this equation, so we will get, that is this packing fraction will be 16 pi 3 upon root 3, and if you put the value of R cube, this will be A cube upon 8 into A square, and this will be into C. So this will be cancelled. So we have 16 pi 3 under root 3 under root 3 8. So this will be C to A. So we have calculated this C upon A, since we know that C upon A is equal to under root A upon 3. So if you put this, it will be 16 pi 3 under root 3 into 8, and this will be under root 3 upon 8 under root 8, so under root 3 into root 3. So if you put this value 16 पाई की वैल्यू पुट कर दें 3.14, 3 into 8 into under root 8. So if we solve this will be 0.74. So packing fraction for SCP will be 0.74. This is for SCP, hexagon close packing. So if you calculate the packing efficiency, this will be packing fraction into 100, so this will be 74%. So packing fraction for this SCP will be 0.74.